pop up again when it stops recording or disappear. This way I can just continue it and attach to the email for you. All right. So we're going to start with solving a system of linear equations. In two variables. Okay, so a system of linear equations is really just two or more equations where they have the same solution, or could have the same solution. Two or more linear equations. Okay. Now a solution is just where you have the same ordered pair will solve both equations. So a solution to a system is an ordered pair that is a solution to both equations in the system. Okay, so let's say, for example, determine if, let me see, where to go? 12,6 is a solution to the system 2x minus 3y equals 6 and x minus 2y equals 0. Okay, so that's a system. It's just two linear equations where if they intersect, that point is the solution. So make sure. There we go. Okay. So make sure that goes up. Okay. Now a solution, you know that an ordered pair, if you remember, is just x comma y. So that means for 12 comma 6, you replace x with 12 and y with 6. Does that make sense? All right. Okay, so we're going to get both of those equations, and if they're both true, then it's a solution. But they both have to be true. If one's true and one's not, then it's not a solution. Okay, so you have 2x minus 3y equals 6. If we replace our x and y, that would be 2 times 12 minus 3 times 6 equals 6. So 2 times 12 is 24. Make sure I got that one right. Yep. 2 times 12 is 24. 24 minus 36 does not equal 6. So we know that's not true. Oh, wait a minute. Where did I get 36 from? 18. Sorry about that. It actually is true. So you end up with 24 minus 18 is 6. So you end up with 6 equals 6, which is true. Let's say I knew that one should have been true. Any questions on that one? All right. Okay, so that was x minus 2y equals 0. Again, replace x with 12, y with 6. So 12 minus 2 times 6, oh, should have gave that a little more room, equals 0. So you end up with 12 minus 12 equals 0, which is true. So that means that 12/6 is a solution to this system, because it's true for both. Okay. Remember that this is all going to be scanned and posted, so if you happen to miss a little bit, you don't have to worry, it'll pop right back up. Okay. So any questions on this one? All right. Okay, so let's try another one. So determine if, let's say, -1, 2 is a solution to the system. Say x plus 2y equals 3, and 4x minus y equals 6. Okay, so what we're going to do, we're going to replace the x and y values and see if both of those are true. Okay, so remember that -1 and 2, that's just your x and your y. Okay, so that means if we have our first equation, x plus 2y equals 3, gives us -1 plus 2 times y, which is 2, equals 3. -1 plus 4 is 3, so you end up with this side being equal to 3, which is true. Okay, so now we'll try plugging it into the other equation. Four x minus y equals 6. Okay, so 4x, so 4 times -1, minus y, so minus 2, equals 6. 4 times -1 is -4. Minus 2 equals 6. If you look at this side, -4 and -2, well, minus 2 is equal to -6. So -6 equals 6 is false. That's not a true statement. So that means that this is not a solution. Doesn't mean a solution doesn't exist. It just means that this particular order pair is not one. Okay? Any questions on that one? All right. Okay, so what we're going to do now is we're going to be able to solve for a solution. Okay. Oops. To ordered pairs. Uh-oh. Not ordered pairs, to systems. Of linear equations. And remember, this is just in 2 variables. We actually do go into 3 variables in the next class, but right now we're just going to do 2 variables, x and y. Okay. Now the 3 types of systems. You have a consistent system. That's where you have at least one solution. Could be more than one, but you have at least one solution. to the system. Okay, now inconsistent means that no solution exists at all, just doesn't happen. And I'll leave a little bit of space because I'm going to draw a graph of each type. So inconsistent system means no solution exists. Okay. And then you have what they call a dependent solution, which means that there are an infinite number of solutions, or a dependent system. Okay. Now, if we were looking at a graph of those for the consistent system, let's say you have your x and y axis. Okay, so let's say we have our, thought I had a different color pen, I guess I don't. You say you have this line of your equation, and your next equation looks like that. Where they cross, that will be your solution. So as long as they cross at least once, it's a consistent system. Okay. Now, an inconsistent system would be two parallel lines. If they both go the exact same direction, they'll never cross, which means if they never cross, there's never a point where both of them will have the same solution. So if they're just going in the same way, you can kind of think of train tracks. They won't cross each other. So if you have those train tracks, or those two parallel systems, or parallel equations, you won't have a solution to them. So inconsistent systems are parallel to each other. Okay, now we have our dependent system, and these are two equations that are really just multiples of each other, where you may have the first equation go like this, and the second equation is just right on top of it. So for example, if you have, let me see, x plus y equals 4, and 2x plus 2y equals 8. Okay, these are really just the exact same equation, but they're just piled on top of each other. Because if you notice, x plus y equals 4, if you factor a 2 out of all of those, you just have x plus y equals 4. So this is just a longer version of the very first equation. So when you have a longer version of the very same equation, if it goes on to infinity, it doesn't matter if it's a little longer, it's still going to go on forever. So when they're piled on top of each other, that means that everywhere that's true for this one is going to be true for that one, over and over and over and over and over. So that's how you have the infinite solutions. Does that make sense? All right. Okay, any questions on this one? All right, so let's go through the steps of actually solving. Make sure, yep. Solving a system by substitution. Okay, you have substitution and you have elimination. We're going to go over both of them. All right. Okay, so let's say, for example, we wanted to solve the system (2x plus y equals 10) and x equals y plus 2. And you usually see a bracket there kind of letting you know that's a system. Now we see here we have an isolated variable for the second one. We have an x all by itself. So since we know that x is equal to y plus 2, we just replace x in the first equation. Okay, so that means that our 2x plus y equals 10. We know that x is y plus 2, so we can just make that 2 times y plus 2 plus y equals 10. Okay. Now once we have that, we have just one variable in that entire equation now. So we can just solve for y. Okay, so that would give us, once you use the distributive property, just go ahead and distribute that 2. 2 times y is 2y. 2 times 2 is 4. Plus y equals 10. Oops, move that up a little bit. We can combine those two terms, 2y and y. So that's 2y plus 1y, which is 3y. Then you have our 4 equals 10. Subtract 4 from both sides. 4 minus 4 is 0. So we end up with 3y equals 10 minus 4 is 6. Now we divide both sides by 3. 3 divided by 3 is equal to 1. So we have y equals 2. Okay, so just substituting that x with y plus 2 gave us y equals 2. So now all we have to do is, now that we have our y, plug it into either one of those equations and solve for x. And we'll have our answer. Me personally, I'll plug it into the second one just because it's easier. You could plug it into the first one if you want, but you don't have to. So x equals y plus 2 means that x is equal to 2 plus 2. Oh, let me know if it's too low. So that means that x is equal to 4. Okay, so your solution is the ordered pair. Remember, it's x comma y. So your solution is going to be 4 comma 2. And you can always double check it by plugging it into your original equations, and you should come out with 2 true statements. So if we plugged in x equals 4, y equals 2, 2 times 4 is 8, plus 2 is 10. So that's true. 4 is equal to 2 plus 2. We already did that one. So 4 is equal to 4. That's true. So if you plug it into your equation, you can kind of double check your work. Yes?
Sorry, where did you get 3 from?
Which 3? I'm looking.
3y plus 4?
3y, 3y, 3. Oh, the 3y, when I connected the 2y plus y. So we have 2y plus, you can really think of it like 2y plus 1y. Remember that 1y is the same as just saying y. So if you have 2y plus 1y, that's just add those two together and take your y over. That makes sense. Okay. Oh, that little square is just one of those, that's the end of the problem type of signs. All right. Okay, so let's say if we have, make sure, another example. Say we want to solve the system. Say 5x minus y equals negative 2, and y equals 3x. Okay, so we know that y is equal to 3x. So we can do what? Yep, plug it into the other equation. Uh-oh. Okay, so that means that our 5x minus y equals negative 2 will just become 5x minus, and instead of y, 3x equals negative 2. Okay, so we have the same variable, same exponent and everything. So 5x minus 3x is the same as just saying 5 minus 3, which would give you 2x once you combine those two. 2x equals negative 2. Divide both sides by 2. Anything divided by itself is just 1. And 1 times x is just x. Negative 2 divided by 2 is just negative 1. Okay. Any questions on that one? All right, so now that we solve for negative 1, x equals negative 1, what do we do? Yep, just plug it into either one of them. Me personally, I'll pick this one because it's easier, but if you plug it into that one, it'll work too. Uh-oh. Into either equation. Okay, so that means that y equals 3x will actually become y equals 3 times negative 1. So y equals negative 3. So your solution, which is always in the form of x comma y, is just going to be negative 1 comma negative 3. Okay. And you can always double check it by just getting those and plugging them into your original equation. So if x is equal to negative 1, oops, sorry about that. There we go. X is equal to negative 1. 5 times negative 1 is negative 5. Minus negative 3, negative 5. Minus negative 3, that minus negative 3 becomes positive. So negative 5 plus 3 is negative 2. Okay, same thing here. If y is equal to negative 3 equals 3 times x, which is negative 1. So you have negative 3 equals negative 3. So it's true. All right, let's end of that one. Okay, so let's try, let me see if I have one here. I'll do one more that just has one solution, and then I'll go to an example to show you how it looks when you have an infinite number of solutions and no solution at all. Okay. So solve the, not system, equation. No, system. Let's say x plus 2y equals 7, and 2x plus 2y equals 13. Okay. Now with this one, you don't have any isolated variable, but you can easily get one. That's the one good thing about it. Even if it doesn't immediately come as x equals something, x plus 2y equals 7, if you subtract 2y from both sides, 2y minus 2y is equal to 0, so that disappears. You end up with x equals negative 2y plus 7. Or you could make it 7 minus 2y. Either one would still work. Okay, so now this system, x plus 2y equals 7, 2x plus 2y equals 13, you can rewrite it. Okay, just subtract our 2y from both sides. You can replace that with x equals negative 2y plus 7, and 2x plus 2y equals 13. Okay, so now we have what we can substitute with. We just had to do a little work beforehand. Okay, so since we know that x is equal to negative 2y plus 7, you substitute. Okay, so that means 2x plus 2y equals 13. We can now replace that x. So that gives us 2 times negative 2y plus 7. All we did was just replace that x with the equal amount. Plus 2y equals 13. Okay. Any questions on that step so far? No, right? Move that up a little bit. Okay, so now once we get rid of it, we just solve for y. Okay, so first thing we do is distribute to get rid of those parentheses. 2 times negative 2 is negative 4. So we have negative 4y. 2 times 7 is 14. So plus 14. Then we have our plus 2y right there equals 13. Okay. So now we got rid of our parentheses. All we have to do now, combine our like terms, solve for y. So we have negative 4y and 2y. Okay. Negative 4 plus 2 is negative 2. So negative 4y plus 2y is negative 2y. Okay, so if we subtract 14 from both sides, 14 minus 14 is 0, so that cancels out. That gives us negative 2y equals negative 1. So if we divide both sides by 2, oops, slide that up a little bit. Divide by negative 2, and that divide by negative 2. Anything divided by itself is just 1. So 1 times y is just y, equals negative divided by negative is positive, so that becomes 1/2. Okay, so now we have our y. So once we solve for one of the variables, we just plug it into either equation and solve for the other one. Okay, I'll pick the first one simply because it looks a little less complicated than the second one. No other reason than that. You can pick the second one if you like, it would still work. Okay, so we, move that, make sure that's up a little bit. We plug y equals 1/2 into the first equation. And remember, you could have picked either equation, it would still work. Okay, so if we have x plus 2y equals 7,